Hi, this is Brian again from the Columbia River Gorge out of my shop, Open Ocean. I have done 5 videos for you folks, and I might have been a bit of a information overload, and so I wanted to do the 6 videos to sort of add to what I forgot possibly, or to make it accent to be more easily understood. At the same time, if you were to look at only the 6th video, you may get everything you need and not have to go through the other 5, or you can choose which portion of the other 5 you want to clarify on, because there is some information there, and for somebody like me that's been in it for so long and can understand everything what I'm saying, it may have caused you to come up with a lot of questions. So hopefully this 6th video will help you diagnose what I'm trying to say, and in the bottom line, makes your sailing better because you found the product you want. It's going to actually work for you in the direction you want to go in your windsurfing. So one of the some of the key points that I touched on, what kind of craft are out there real quick. There's planing, which is windsurfing, water skis, motorboats, all those are planing craft. And boats like the Queen Mary, the Titanic, battleships are all displacement hulls, and of course there's submarines. So in windsurfing, we start out as a displacement hull, which is probably the most terrible design for a replacement hull, and we struggle to get on plane. So we're going to move on from there, and I think part of the problem with understanding what volume does, because I think there's some misunderstanding going on there. A ship like the Queen Mary, she's out sailing, the captain sees that it's going to be really rough, treacherous condition. He takes on ballast, which he pumps water in the hull, lowers the water line, gives the sailor, gives the people, the customers a better ride by lowering his water line. Lowering our water line going to a smaller volume board doesn't work like that. I'm sorry to say, once you're on planing, volume is almost zero in the equation except for its weight. What I tell people to do after they usually come to my shop and they talk design with me is stick your hand out the window as you leave here, and as you go faster and faster, their hand goes up in the air. Air is hitting everywhere, just like water on the bottom of your board. It's doing the same thing. According to Bernoulli, liquids and gases work exactly the same. So as you go faster, your hand comes up. At this point, it's at maximum drag. At this point, you've actually reduced the drag by 25%. You can see this as you go faster, turn your hand like that, you'll gain instant control. Well, this represents narrow board, wide board. I put a block of foam on the outside of my hand. Does the hand or the air hitting the bottom of my hand know that there's a block of foam there? What is it really doing? Well, it doesn't. Nobody's telling it. What is actually done is add more weight. The theory is more weight out there gives you more control. So we've added weight. So actually more volume you add to a product would be more weight, more control. So it kind of shoots this theory out of what volume makes you bounces out of control. Now, in the first video, we talk about Bernoulli's principle of plane. Let me grab my prop here. It's a little surfboard, wooden surfboard I'm using for a prop, and as I move this through the air, air strikes everywhere at the same time as if it was in the water. As you move forward, X amount of water is pushed forward. This is Bernoulli's principle, a mathematician, been around for a long time. He calls it your forward stream, we call it a bow wave. At the same time, water comes under your board, turning your laminar flow and your wetted surface drag. But in between those two flows, there's water trapped. That trapped water becomes forced out the side, creating a static backup pressure. And according to Bernoulli's theory is, it creates 85% of the lift that brings you to plane. Once you're on plane, it's canceled and you're dealing on reflective pressure. Now, as you go faster, you need less and less wetted surface to obtain plane and efficiency. Now, Bernoulli's other principle of an airplane wing, it sets at an angle of incidence. If it's parallel to the fuselage, you couldn't fly, but when it's at an angle, creating a high pressure and a low pressure. Well, in windsurfing, or even in surfing paddling a board, as you add If this was a 280-liter board, and as you took the volume out of it, you're increasing your angle of incidence to the flow of the water. So, and you add volume, you're changing it, but it's always, the factory board back here is going to set at an angle and incidence. But when it's like this, because you're a big guy on a 60-liter board, you're trying to make this work, this is pushing all drag. As you gain volume, you reduce drag. So that helps you come to plane. Now, what's beating us up out there? That's chop, swell. We're an energy source going. The chop, the swell is an energy source, and we collide. For every action, there's an opposite and equal reaction. So we're bouncing off, or we're plowing through it, depending on a lot of stuff, times what weight of board we have. It seems like a heavier boards drive through this stuff a lot easier, and they're easier to maintain and higher wind. And a lot of that comes down to what you like. Nobody's going to, the whole windsurfing world that you're trying to discover is what works for you, what's going to put the smile on your face. Because remember, we do this for fun. I'm basically saying out of this is more volume boards bring you to plane better because they change your angle of attack and reduce the drag. Wider boards grab more water, grab more pressure, according to Bernoulli's principle, and brings you to plane. Most of the time when you look at a bigger volume board, almost 100%, you're going to find a wider board. So when you take a 24-inch wide board, and if it's 60 liters and 80 liters, there's two different ones, the 160, 180, and you took them out and rode them in high wind, you're going to feel almost the exact same thing. Actually, the bigger volume board, because more volume weighs more, would probably give you more control than a lighter volume board. So weight does make a difference. Weight is the only thing you're getting out of volume once you come to plane. So, as I move through here, because it's really important to get this thing down right so I can relate to you what the real deal is. So the bottom line is, width creates the lift, volume helps you plane, and actually more volume gives you more control and higher wind, because it is weight. Now the other thing they talked about, the second subject, was outline template. The outline template is probably the second thing that's the most important when it comes to making your board work. Rocker was the first, outline template would be the second. Now, over the years, and I call it the Ferris wheel of design, it's a lot of guys who's only been shaping for maybe 15 years haven't seen this, and they bring it up and they think they're revolutionized things, and there's very little things and on the Ferris wheel that hasn't been brought up 2 or 3 times. I've seen stuff come up for a long time. Wide point. 10, 15 years ago, it was a narrow nose with a wider back was the supreme being. Now it's fuller noses, just the opposite. For a long time, the wide points were more like foils from back in the 80s, which came out of surfing. A lot of us came out of surfing, so we took our surfing knowledge, put it to windsurfing, so we ran with that for quite a few years. Windsurfing for the 36 years I've been in, I feel like I've been in the fashion business for 36 years, and I struggle to help people say, here's the facts. Don't worry about what the magazine's saying. Here are the facts. And look at it as a scientist, which I'm trying to relate to you right now. So the bottom line is all these wide point forward, wide point back, they all work. But what works for you? That's what you're trying to decide. If you've been sailing since the 80s, you've seen a big variety of concepts of designs come and go. And if you're writing the newest thing because you get to put a lot of time on it, then congratulations. But you can't say that's better than something you had before. It's different, but no one can say it's really better. It's just what's better for you and what this whole windsurfing gig is about. Now, I talk about wide boards versus narrow boards. And I use the thing about the race car, the wider boards, further back, basically the wider the board, the sooner the tail walk. If you have a lot of area in the back of your board with a 15-inch tail, your board's going to be out of the water. It's creating X amount of wetted surface to create the lift you need. And as you're going faster and faster, we all get to the point of tail walking. Well, if you have a wider board, that tail walking is going to develop sooner because it's developing more pressure. And due to your weight and your ability, you can't hang on it anymore. The second fact is if a narrower nose up there is creating less wind resistance, creating a pressure zone, just like hitting the bottom of an airplane wing, creating lift. So if it's wider up there, it's creating more air to get trapped under your boards, helping the tail lift situation. So this is all comes down to what works for you. You know, in the old days when you measure your board, when I went in there and I drew an outline for you, there's 4 measurements: the length, the width, the foot off the nose, the foot up the nose from the tail. Is the most important measurements you got to work is the width of the board, where it's at, and the width of the tail. So a sailor, I came up with some measurements on how to measure volume, which I'll go over again. I didn't mention it earlier, about positive, neutral, and negative buoyancy. At the same time, how to measure some kind of a lift situation here. So if you're a 120-pound person, and the board you're trying to ride is 21 inches wide, if you divide 21 into 120, you get 5.7 pounds of her weight holding down every lineal inch of lift that she has. You can do this, everybody can measure this out and figure out where you're at. Measure the width of the board into your weight, you'll come up with a number. Now if you took the same board and you measure it with a 180-pound person, he's got 8.5 pounds that holds that board in position, as she only has 5.7. So he's about 40% more weight per lineal inch, so when it gets really wound up, he can hang on to it, she can't. Now, this is what it's all about, finding the right width of board, just like the volume. You find the volume that you're comfortable with, so you can slog around, come to plane earlier, in between the holes, you're not burning up all your energy struggling, doing the hula. So there's a volume that turns each one of you guys on to where you're happy out there all the time. Find that volume. Then build a board around with the width you need to hold you in higher wind conditions that gives you enough early planing where you're not struggling, getting mad. Just get out there where you're tempted because it's not blowing 26 knots, and at 24 knots you got to swim in. Find that volume and that width is going to pertain to what your fun level is. The next thing I talk about is rocker line and the measuring system. You can go back to the video there of how I come up with 3 different rocker lines: my come to plane rocker, my working rocker, and my top end rocker. We talked about different slalom rockers are usually straighter and they're made to plane sooner, and a lot of the courses are set up in only like a 300 or 400 yard fetch, and you jive and you can go accelerate really fast. You know, anything can be designed. We're human beings. We can come up with any kind of design we want to work and fit to the conditions. If you're riding a slalom board 16 miles across a big straight and it's really choppy, and you're riding on a 12-pound board, really wide, really straight, it's going to be probably a fast ride if you can hang on to it, if you can hang on to it. So everything has a design purpose. You know, wakeboards have a lot more rocker. They don't plane as well, but they turn really well. When you're riding a wave, you have the parent speed of the wave to enhance your sailing experience. The next thing that we want to go to is construction. We talked about different densities of core, that what represents the weight of the board, because the same amount of glass and resin has to be put on that board to keep it together. Same amount of foot straps, deck box, fin boxes, all that's neutral. So the only thing that's changing the weight of the board is what the core is made out of. I talked about extruded polystyrene, expanded polystyrene, and PU foam were the 3 most popular. I use all 3 in mine and come up with 3 different weights of boards. So the weight of the board differs only what the core is made out of. That's the only thing changing anything in the weight. And from a difference from you can get an epoxy board at 13 pounds, the same board and a glass board may weigh 17 pounds. If they're the exact same weight, it's just because of the density of the core, and the core itself weighs more, you come up with a heavier board. The interesting part is if a sailor weighs 180 pounds and he rides an epoxy board at 13 pounds, and the weight of the rig is, I weighed him right around 25 pounds. So you add those all together, that's 218 pounds. Now a glass board weighs 4 pounds more, so you just add that 4 pounds and you come up with 228 pounds. The amount of energy your cell to bring you forward, difference between an epoxy board and a glass board that weighs 4 pounds more, is not even 2% difference in coming to plane. Now at the same time, when you jump, a light board's not going to go any further. It may go a little higher if you can measure 2% or less than 2%. The formula for big air is big speed. Faster you go, the higher you go. Ask Evel Knievel. Too slow, he was dead. Too fast, he overjumped his landing port, and he was in the hospital. So the crucial point, if you're going to get big air, you got to go fast. That's just the secret of getting big air. Now the interesting part of this 4 pounds difference in the weight, you have to look at the board. The glass board is 30% heavier. Well, inertia wants to travel in a straight line. Inertia is in mass. You have kinetic energy, you have forward momentum, you have retained energy. Now, the fact that the board is 4 pounds heavier, it has more inertia, more kinetic energy, and more retained energy. So what happens is when you go to drive that board, it takes more energy to redirect those forces. Once you redirect those forces, it wants you to pull you through the turn. As a lighter board, doesn't have as much of that. It's got 30% less. So it does it, you can, because they're so light, you can overturn them. You've got to make a bigger arcing turn. Now, this is all about retained energy and kinetic energy. So it comes down again what the sailor is like. If he's never ridden a glass board, and people get on him, they feel like they don't want to turn. Well, when we moved the mast track back, made the tilt a little wider, moved the foot straps back, we instigated and put more energy in making a board do this than straight line, flat out control and go faster. In the old days, when I first started building sailboards, the foot straps were right in the middle of the board. They were 18 inches from the tail. Then we went to 15 inches from the tail. Then we went to 13 inches from the tail. We finally are about 10 inches from the tail. Everything's rigged back to do this. Well, when you're doing this, everything's so far back, you're tail walking sooner. It's hard to hang on to stuff in the chop, bouncing around because everything's meant to do this. That is part of the reason why you're out of control in these wider, new, wider boards enhance all that stuff. They enhance turning, but you lose control in high-speed, bumpy, wound-up conditions. And believe me, in the last 22 years, that's what I've been designing boards for. I was a wave sailor for a long time in Hawaii before I moved out here, so I know what wave sailing is. It's a different animal. Now, the last thing that I touched on real quick was some simple fin designs, and we talked about rake fins or projection fins and pivot fins, or fins that are more straight up and down like blade fins. They want to pivot in a turn. They don't want to project you out of a turn. You can look back and get a better idea. A bigger fin planes better. It's create more lateral resistance. A smaller fin goes faster. But if the smaller you go at a certain point, remember, sailing's calculated drag. If you go too small, you start washing out. The other problem that a lot of people are having is when you move your mast track back, when you oversheet, your center of effort is going behind the fin, it loads it up, and you wash out. You're not really stalling and spinning out. You're just loading up that small fin so much, you're washing out. There's a big difference between, we don't cavitate in windsurfing. We stall when you spin out. We're not ventilating. We're stalling due to the simple fact that we're putting a lot of pressure on our fin. Remember, the fin is an airplane. It creates a low pressure and a high pressure. So, and if you don't try a lot of fins, if you're not moving around and looking for something that fits your style, you're really losing out in windsurfing. Remember, like I do, I find a fin that I move it from board to board to board. In the end, after 6, 7, 8 years, the thing wears out, and I battle to find the same fin again, because that fin is representing how I like to sail. The position of that fin is really important. You move your fin a ½ inch up, makes it maybe the worst jibing board you ever rode. Position is really important. That's just something we all started out, we put our fin in position, our adaptive sailing to those positions, and you jump on somebody else's board with their fin further back, and you come in like, I can't ride your board. Well, that's a normal thing. So remember, biggest point of all these videos is out, get some knowledge, get your tape measure out, measure where you're at on your board. What is happiness? If you're riding a 90-liter board that's 23 inches wide with a 14-inch tail, and you're really happy, when you try to ride a bigger one, analyze what's the difference. Now, I hope that this whole situation of some knowledge, that some real hardcore, a lot of weight from just repeating what scientists and theologists like Bernoulli and a lot of guys are out there, I got to expand my knowledge over 44 years, and I'm trying to relate that to you folks now. So I hope this has helped you out, and if there's any questions, give me a call. I'm sure I can answer them, and maybe possibly down the line I'll be taking questions and answering on YouTube, and a whole new series of trying to understand why you're having problems. Take 5 or 6 questions, make a new video, and come up with some stuff that'll help everybody. So thanks a lot, and I really appreciate the time we're watching this, and have fun sailing. Remember now, you want to be the fastest guy out there, just go sail by yourself. It works every time. So thanks again. Bye.